Hello and welcome to my channel. In this session we are going to learn on one of the most well-known machine learning algorithm called as Xgboost. So this algorithm is one of the most popular machine learning algorithm as it provides better solutions than any other machine learning algorithms. Xgboost algorithm is an implementation of gradient boosted decision trees designed for speed and performance. This algorithm can be used to solve regression, classification and any other user defined prediction problems. Right. So in this session let us try to predict if breast cancer tumors is benign or malignant. Let us have a look of the data set. So here each row of the data set corresponds to the certain patients, and for each of these patients we have several features starting from the clump thickness to the mitosis. Okay, so which are the characteristics of a tumor, and with all these features we are trying to predict if the tumor is benign or malignant. Okay, so it is benign if we have a class as 2. Okay, and malignant if we get a class 4. So here we build and train all your classification models to learn the correlation between all these features and that dependent variable vector telling if the tumor is benign or malignant. Okay, and of course when we try to run this various algorithm on this same data set, we have found that decision tree classifier and support vector machine are having a better accuracy compared to other algorithms such as logistic regression, okay, kernel SVM or random forest, and we got the decision tree classifier accuracy as 95.9%. So now we are going to build the Xgboost model and train it on the same data set to see if it can beat that accuracy obtained with the decision tree classification model. Okay, and not only that, we will try to test on the single test set, but also of course we are going to test this on 10 test folds using k-fold cross validation technique. Now let's try to implement this using Python. Okay, and in this data set we have altogether 683 instances here. Okay, 683 instances we have, and with the n number of features. These are all the characteristics of a tumor which is present in breast. Okay, so let us try to implement the same using Python here. Okay, now let's try to import the necessary libraries. The library what we required here is a pandas, so we had imported it here. Let us execute that line of code. After doing that, we have to import the data set. Okay, the data set name is data.csv, which contain all the features of the breast cancer tumors. Okay, so we will import that, and after we import that, we can see it in the variable explorer. The data frame has been created here. Okay, that is this data set here, right? And we can see that all the data have been successfully imported to the data frame. Okay, so after this we are going to split the data set into matrix of feature x and dependent variable vector y. Okay, so to do that we have to identify the index location and we have to split the data. Okay, so in the data set, all the rows, all the columns except the last column, we are going to consider it as the matrix of feature x, that is the independent variables, and of course the last variable will be considered as the dependent variable vector. Okay, and that is stored in y. So this is how to do that, and we'll execute this. And after we do that, we have to split the data set into training and testing. And to do that, we have to import the class called as train underscore test underscore split. Okay, from the model underscore selection. So out of 683 instances of data, 20% we are considering for testing, and the rest 80% will consider it for training. Okay, and this is how we split the data set into training and test set. Now it's time to train the Xgboost on the training set. Okay, As I already mentioned that I tested the same data set with the various other machine learning classification algorithms. We are tested with the logistic regression, decision tree, support vector machines, naive Bayes classifier, KNN, kernel SVM. Okay, we are tested with also the random forest. Okay, but among all the algorithms, we have got better accuracy for the decision tree algorithm. Okay, with the 95.9% accuracy. Now we have to check that whether we are going to get a better accuracy than the decision tree classification algorithm or not. So to do that, we have to import the class called XGB classifier here. Okay, XGB classifier, and that we have to import it from this library Xgboost. Okay, we have to install this library first. Okay, in the terminal pip install Xgboost. Once it is successfully installed in your machine, then only you will be able to import this class XGB classifier. After we do that, we have to create an instance of the class, and luckily we don't have anything to pass it as a parameter. All the default values will be sufficient enough to get a better accuracy here. Okay, so that's the reason we are not passing any parameters here. And of course, after we create an instance of this class, we are storing it in object classifier, and then we are going to fit that model to the train data set. Okay, x underscore train and y underscore train for the independent variable vector and the dependent variable vector. Okay, so let us execute these 3 lines of code here to train the XGBoost on the training set. And once we are done with this, we have to estimate the performance of the model through confusion matrix and accuracy score. And to do that, we have to import these 2 classes from metrics module, and of course we have to invoke a method called as predict, and predict it through all the values of the x test. Okay, and store it in an object ypred, and later on you are going to pass this y test and ypred as a parameter to the confusion matrix. Okay, so wherein the first value will get the testing values, and next value will be the predicted value. And using the confusion matrix, it will be very clear that how many right and how many wrong predictions have been made. Okay, so to do that, we have to execute these lines, and let us try to print that confusion matrix. So 20% data has been taken among 683, and you can see here, so except the 3 wrong prediction, rest all the predictions have been made correctly. Okay, now to estimate the accuracy of the model, we are going to pass the same 2 parameters for the accuracy score, and let us see the prediction. Excellent. And you can see that we have got an impressive accuracy of 97.8%. okay, having only 3 incorrect predictions on such sensitive problems. Okay, and that's a great job, because we have really tried to overcome the accuracy what we have received in decision tree classifier, right? And but now we have to check with the multiple test set results using k-fold cross validation. Okay, so to do that, we have to split the data set here using cross val score. This is the class which we are going to import from the model underscore selection, and as a parameter we have to create an instance of the class and pass the parameters here. Estimated will be the classifier. Okay, so the classifier is a XGB classifier, and we have to pass the matrix of feature x and y, x train, y train, and the number of splits. Okay, number of k folds which we are utilizing to cross validate our model is CV, that is 10. Okay, CV equal to 10. And finally we are going to print the accuracy and standard deviation. Primarily we are going to format the specifier to 2 decimal values of float, and we are going to calculate the mean values of it, right? Because of course whenever we try to attain the accuracies, it is going to take the average number of accuracy, right? Of course it is going to make an average of accuracy obtained as a result of the average of 10 different accuracy, and which is measured on 10 different test sets. Okay, so we have to do that. That's the reason we are going to take the mean value of it, and finally to present it in terms of percentage, we are multiplying this by 100. Okay, and of course we have the small variation in the standard deviation also. Okay, to understand how much results has been deviated from each and every accuracy. That's the reason we are going to measure the standard deviation of the model by invoking a method called STD, and similarly multiplying it with 100. Let us execute these lines of code and let us see what is the final accuracy and the standard deviation. And you can see the average of all the accuracies after 10 folds, means 10 accuracy you have got. After taking the average of all the accuracy, the mean value of the accuracy is 96.53, and of course all the 10 test folds for which we are tested, the standard deviation was only 2.63. okay, it's a great job, right? We have very small variation in the standard deviation of about 2%, correct? So with this we can come to conclusion that XGBoost classifier is a super machine learning model when compared to any other algorithms in machine learning. Okay, so with this I would like to end this session. Thanks for watching the video and happy learning.